say that one more time since I just started hit record. Let's see, today is block day, January 24th. Worksheet, or notes 4, solving trig equations. It's a combination of unit circle and algebra. So if you know your unit circle, most of you do. If you're good at algebra, most of you are. It's just the combination of those, and the mistakes will occur in one of those spots. And sure, you make a mistake once in a while, but if your unit circle is strong and your algebra is good, then this is no problem today. All right, number 1. In fact, there's no new concept, so we just jump straight into examples because all we're going to do is apply unit circle and algebra. Number 1, f of x is 4 cosine squared of x. Determine the values between 0 and 2 pi. That's nice. That means that makes me think unit circle, like just one time around, such that f of x equals 1. F of x equals 1. So they kind of phrase this a weird way, but basically 4 cosine squared x equals 1. So, algebra all-stars, what do you think we should do first? Divide by 4. What do you think we should do next? Square root both sides. So cosine of x equals 1/2. Yes or no, my algebra all-stars? Plus or minus. Plus or minus. So there's maybe the main point of that problem right there. So I want to know where the cosine is equal to plus or minus 1/2. Maybe I'm the only one that needs to draw a picture. In fact, pi over 3. Well, careful, I want all of them between 0 and 2 pi. So yes, negative pi over 3 fits the equation, but it doesn't fit the range we're allowed to look in. So they're definitely all over 3. So pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. But not negative pi over 3, because that's not between 0 and 2 pi. M is the function defined by 2 sine squared plus sine minus 1. Determine the values of x in the interval 0 to 2 pi, which give the zeros of m. Alright, so worded kind of funny, but set the function equal to 0. That's what find the zeros means. Oh, algebra all-stars? You can factor that. We don't usually factor things that look like that. And if it bugs you, you could put a u in there if that helps you see what we're doing. Helps you factor it. So I'll probably use a u this time, and after this, I probably won't use the u's again. It's got to be 2u and u. It's got to be 1 and 1. And I want the inside to be positive, so let's make that plus 2u and minus u. Which means that, I didn't really say this like I should have, u is sine of x, so now I can go back and put the signs in there. So 2 sine of x minus 1, sine of x plus 1 equals 0. My thought, my hope really is that many of you are probably going to skip the u substitution business and just factor the thing. But occasionally you get one that looks weird or you can't figure it out, and seeing it with u's maybe simplifies it. Your brain recognizes it a little quicker. So, do what you need to do. If you need the u's, use the u's. If you can skip over that, skip over that. Set each factor equal to 0. So sine of x equals 1/2. And sine of x equals negative 1. I'm going to rewrite those up here. Just, I don't know, So sine of x equals a half. There's actually, I guess, two ways to think about these problems. I think unit circle. I'll show you the other way in a minute. So when I'm thinking unit circle, let's see, sine is a half. Sine's positive on the up quadrants. So that would be the first and second. Sine is a half at the shallow angles. So that's pi over 6 and 5 pi over 6. Sine is -1. That would be the down spot down there. So this is sort of backwards from the inverse trig stuff. When we were doing inverses, you had to say negative pi over 2. You had to go the quick way. But now I have to give an answer between 0 and 2 pi. So it's 3 pi over 2. So be careful. Like, that's why we say, are 3 pi over 2 and negative pi over 2 the same thing? No, they're coterminal. They land in the same spot. But depending on the problem, sort of determines which answer you give. Okay, that's the unit circle way to think of these problems. That's the way that makes the most sense to me. That's the way I do it. I've taught this before, and some students swear they don't like it. They like to think about the graph of sine of x. I guess that is more recent, and maybe, so if your brain is thinking, there's the graph of sine, and the sine is equal to 1/2, like right there, and that would be pi over 6 and 5 pi over 6. And it's equal to -1 right there at 3 pi over 2. I suppose you could do it without a picture at all. Your brain could just think and know where the sine is a half. But to me, I know the unit circle well. It all comes from that. So my brain thinks unit circle. But there are people whose brain thinks about the graph of y equals sine x, and they sort of pick the answers off of that graph rather than the unit circle. It's the same, whichever way your brain thinks about things is fine. Number 3. Let f and g be the functions given by this and this. Find the values between negative pi and pi. Okay, so we got to be careful here. This is a different, we're not 0 to 2 pi anymore. We're negative pi to pi, such that f equals g. Okay, so sine of x tan squared of x equals 3 sine of x. Okay, Algebra All-Stars. Say that again, Andrew. No, I wanted you to say that because it's tempting to do that. Right? Because if you divide both sides by sine of x, then it's tan squared equals 3. Square root both sides, you're off and running. Do you know why you don't want to divide by sine of x? You don't know why, because that's why we wanted to do it. You don't want to ever divide both sides of an equation with something involving an x, because you lose a solution. A little side note here. If x squared equals 9x, and you divide by x, you get x equals 9. And that's not wrong, but what else could x be? Just look at that. Not 3. Not plus or minus, because this side would be positive, this side would be negative. Well, let's work it a different way. Let's move the 9x over. And then you could factor out the x and get x equals 0 and x equals 9. So when you divide both sides by an x, you lose a solution. So your answer won't be wrong, it will just be incomplete. So given what we did on this little example problem over here, what do you think we should do with our original problem? Move it over and factor it out, and I guess you could do both of those steps at once if you were feeling adventurous. So let's move the 3 sine over and then factor out the sine. So we do end up dividing by sine, but we don't throw it away. We divide by it and move it out front. Okay, so now I've got a factored equation, so sine of x, whoops. I'm going to factor out the sine of x. This is like 7 tangent squared x minus 21. I could factor a 7 out of both of those.
Then wouldn't it be like cosine squared x?
Okay, I'm not taking it out of the tangent. You could do that. That would be crazy. It wouldn't be wrong. It would be weird to do that. It's already sine times tangent, so I'm going to pull the sine off of that. Not out from the tangent. You got it?
Yeah.
There's still a sine over cosine in there, yes. I didn't take it from the tangent. I took it from this term. And the second one would be tangent of x equals, move the 3 over, square root both sides. Don't forget the plus or minus. And again, my brain thinks unit circle. If your brain thinks graph, go for it. So sine of x equals 0 there and there. So that would be 0 and pi and 2 pi, but I can't really use 2 pi. So I've got to think about going this way and going this way. I think there's one more answer to be had. Negative pi. Which is maybe a little weird because negative pi and pi are the same spot, but I can get there 2 different ways. The unit circle way would look like that, and so it's equal to 0, and excuse me, not the unit circle way, but the graphing way would look like that. I agree. I'm shaking my head at that, but I've had students who prefer the graphing way. Tangent of x equals plus or minus square root of 3. I don't know that unit circle really helps here. I know that the tangent 3 trick is the answers are all going to be over 3. I just got to figure out which over 3s they are. It's plus or minus, so the short answer is it's all of them. Yeah. Now I need to be careful. I need to make sure I describe them the right way. But yes, it is all of them. So pi over 3 and 2 pi over 3, that's those two. And then, right, 4 and 5, but that's not going the right way. This time it wants me to go backwards and say negative pi over 3 and negative 2 pi over 3. And then all of those are my answer. And you're crazy if you do that one the other graphing way, right? Like if you're thinking the graph of tangent, it looks like that. You're right. There's an asymptote at pi over 2, or pi over 2. But where is square root of 3? There, I guess. No. I like the unit circle way. Number 4. Find the x-intercepts. So that's where y equals 0. We're sort of as algebra view built in. Like how many different ways can we say set it equal to 0? Find the zeros. Find the x-intercepts. Set it equal to 0. Set them equal to each other. Cosine of 2x minus cosine of x equals 0. Uh-oh. Those are different things, right? So can't really factor out anything. What did we do yesterday? What's cosine of 2x? What's another way to say that? Cosine squared x minus sine squared x. So, well, was that helpful? Kind of. All my arguments are the same, so that's better, I guess. It'd be nice if sine wasn't in there, like if everything was in terms of cosine. If only there was some identity that related sine squared and cosine squared. So that means sine squared is equal to 1 minus cosine squared. So in place of sine squared, alright, let's see how confusing we can make this. Minus, but big parentheses, because we want to subtract all of this thing. 1 minus cosine squared x minus cosine of x equals 0. Okay, I have everybody in terms of cosine. I only have x as an argument. The 2x isn't there anymore. Let's distribute minus sign. Let's see. Oh, we have a like term here. So 2 cosine squared x, and then I'm going to rearrange them in descending powers of cosine, I guess is the way to phrase that. Trig step in there, and then algebra steps. Thoughts on what to do next? This looks a whole lot like number 2, factor. And I'm running out of space, so I'm not going to do the u stuff. It's got to be 2 cosine and cosine to get 2 cosine squared. It's got to be 1 and 1 to get 1. And then I want the middle term to be negative, so I need that guy to be negative, so he will attach and make negative 2. And this would be positive 1. Yes? So if I FOIL that, these two make positive 1, and these two make negative 2. Oops. Equals 0. And then this is the point of factoring. You take one hard equation that you can't solve, and you turn it into 2 easy equations that hopefully you can solve. Now, there's a step I probably could have skipped, but set each factor equal to 0. Cosine of x equals negative 1/2. Cosine of x equals 1. Now I'm looking from negative 2 pi to 2 pi. Okay, so like unit circle, that means I can rotate all the way around forward one time, or all the way around backwards one time. Let's see, cosine is negative on the left. Cosine is 1/2 at the over 3's. So that would be 2 pi over 3 and 4 pi over 3. But that's not all. That's only the 0 to 2 pi answers. Oh, I could shortcut things and make them both plus or minus. Does anybody see where that comes from? Going backwards would be negative 2 pi over 3 and negative 4 pi over 3. And so, yes, you can just make those plus or minus. Be careful, that doesn't always work. So, use it when it fits, but don't always just go throwing plus or minuses on everybody.
Do we have to worry about the all students do calculus thing?
Yes, but I would say I already worried about it when I said that the cosine is negative on the left.
Okay.
So I'm only going to be in the second and third quadrants. Cosine is 1 over here on the right. So normally I would just think of that as 0, but I could go all the way around. And I could go backwards all the way around. So again, I could do plus or minus, or I could just write them separately if that's how I see it. Again, I'm going to drop drawing these graphs because I don't like doing it this way. But some people like to see the graph of cosine, and then they can visualize where cosine is 1 at negative 2 pi and 0 and positive 2 pi. Number 5, find the zeros. Okay, so set this thing equal to 0. I do like that we're kind of on our standard unit circle for this one, so I don't have to worry about going backwards or going more than once around, or just the regular 0 to 2 pi unit circle thing. Uh-oh. In place of sine of 2x goes 2 sine x cosine x. Let's see, how many steps do we want to skip at once here? The correct answer is all of them. Maybe not all of them. I could take a sine from both of those. That would leave 2 cosine squared. And one of my all-time favorite algebra mistakes, minus 1. Some people are like, oh no, I took the sine, so it's gone. You're like, well, I mean, I guess, but if you want to distribute it back, you need that 1 in there to sort of hold its spot. So sine of x equals 0. Cosine squared x equals 1/2. Again, skip the step or two in there. So sine is 0 at 0 pi and 2 pi. At 0 pi and 2 pi if you're a graphing person. Square root both sides. Cosine of x is plus or minus. Square root of 1/2. That doesn't look like a unit circle type of thing until you fix it. Root 2 over 2. And again, it's kind of nice when the plus or minus is on there, because then you don't even have to think about the all students take calculus, because you want all of them anyway. The root 2 over 2s, that's the middle ones, so I just want all the over 4s. So pi over 4, 3 pi over 4. Yes, I do need to be careful about the second or the third and fourth quadrants. I'm not going backwards to get there. I'm going forwards to get there. 5 pi over 4 and 7 pi over 4.
On the test, is it going to say like how many answers we should have?
Not directly. I mean, like this limits the number of answers you have, but it's not going to say, hint, there's 7 answers to this one. Number 6, function h is defined by that thing. Determine all the values which satisfy h of x equals 0. 3 cosine x tangent of x minus root 3 equals 0. Okay, we've done this before. Set them both equal to 0. This 3 doesn't really do anything for me. Cosine of x equals 0. Tangent of x equals square root of 3. Oh, I see what's different about this one. What's my limitations on where I'm allowed to look? That's kind of a trick question. All of the values of x. How many values are there? Speaking of infinite. So I've got to come up with some way to, express those answers without writing them all down, because that would take a while. So I'm going to need a k situation. So let's figure out what the answers are, and then we'll figure out the k. So this is not a memorize k plus. Just let's figure out what the answers are, and then we'll figure out the k thing. Okay, so cosine equals 0 there and there. Okay, so how could I express there and there? Yeah, infinitely. One of them is pi over 2, so that's an easy start.
Pi over 2 times k with k is equal to? No, because it's 3
No, because that would get you pi and 2 pi and...
It's 3 pi over 2 is like the next interval.
Right. Maybe phrase it this way. How far apart are my two answers?
1 pi. What?
They're pi apart. So one way to say this would be pi over 2 plus pi k, or k pi. Where k is an integer. Because pi is 180, so I could rotate 180. Another way to say that might be more helpful, because normally the period for cosine is 2 pi. So if you want to sort of handle them separately, you'd say pi over 2 plus 2 pi k and 3 pi over 2 plus 2 pi k. Like, this is the same set of answers. Does that make sense? I'm putting this one up there because sometimes you have to go this route. This one, they happen to be pi apart, so you could catch them all with one statement. Other times it's going to take two statements to get there. So either of those statements is the same set of answers. K is an integer. All right, I've got another half of this problem here. Tangent is root 3 at the over 3's. Let's see, positive, so first and third quadrant. So pi over 3 is one answer. How much of a rotation is it to get to the next answer?
Oh, wait, that just
Pi. It's a 180 rotation. It's pi away, and then pi away, and then pi away. So it's kind of the same thing, plus pi k, where k is an integer. K is any integer for this particular problem. Andrew was trying to come up with a way to say it as k is even or odd, and there probably is a way to do that, but this is the way we saw it. This is one where there's more than one way to get there. How did we know that k is an integer? To get from this answer to this answer, I rotate pi, 1 pi. To get from this answer to this answer, I rotate another pi. So I rotate 1 pi, and then 2 pi, and then 3 pi. So k is an integer. Yes. But be careful, remember, if you had to go all the way around, that would be 2 pi.
So then what's the odd and even stuff?
It didn't show up on this one, so I didn't have to worry about it. Although I do think maybe there's a way to, I don't know, there might be a way to express this one with odds and evens. Let's do one more of this all values business, because k pi is going to show up again. Or k2 pi maybe. 3 tangent of x sine of x equals tangent of x, so I'm going to move the tangent of x over, make it equal to 0. Factor out the tangent of x. That leaves 3 sine of x minus 1 equals 0. So tangent of x equals 0, and sine of x equals 1/3, which doesn't look like a unit circle value, so we'll come back to that in a minute. Where's tangent equal to 0? Let's see. Or if you need to think about it, that means sine over cosine is equal to 0. So that would happen where sine is 0. And maybe it's helpful to like write them out. Write out the first however many answers you need to. And then you realize, oh, well, that's just k pi, where k is any integer. 0 is an integer, so that works. That catches 0 as well. Some people, there's a million different ways to write this. If you looked at this answer and said, oh, it's pi, but I could rotate pi forward or backwards. So you could write your answer as pi plus k pi. That's the same set of answers. I don't like that answer as much, but it is the same set of answers.
Could you also do like a million pi plus k pi?
You sure could. Yep. You could. As long as it's an integer multiple of pi. Start wherever you like. All right, sine of x equals 1/3. Not a unit circle thing, so I really got to be careful here. Sine's positive in the up quadrants. So I know it's there and there, like on the picture, but I don't have a memorized angle that has a sine of 1/3. So arc sine of 1/3 would give me this angle. Right? Arc sine means find me an angle whose sine is 1/3. The trouble is that didn't give me the other angle. Right? Because arc sine has to come from 1 and 4. So how do I come up with this angle? It's not arc anything. It uses arc sine of 1/3. It's related to negative. Let's see. Because these two things are equal to each other. So it's pi would be all the way to here, and then if we back up arc sine of 1/3, that would get us the second quadrant answer. So arc sine is always going to be in the first or fourth. Pi minus is going to give us the other answer. And by the way, for sine, it's always pi minus. I don't know that you'd memorize that because you can just figure it out every time. Let's be careful. Although this one's kind of easy because take the easy way out. If I rotate 2 pi, I'll hit it again. So I'll just tack 2 pi k on the end of those. Lovely. Alright, today's assignment is worksheet 4. Due Friday is not worksheet 4, but worksheets 1 through 3. By the way, you peek ahead. We're basically done with new stuff because we'll do more practice with trig equations on Friday, and then so that's kind of review, and then 2 days of review, and then the test. So if you understand everything perfectly, then you're good for the test, but that's probably not very many of you. That's why we've got a few more days to work on equations, review a little bit, and then test next block day.